Hello guys, welcome to leetcode, and in today's video we will discuss the question that is asked in Google. So this question is not that old, it was asked in July 2022 and here it is posted by an anonymous user. This question is very much similar to today's daily challenge of the leetcode that says restore the array. So I have already made a video on this question. So guys, make sure you check this out and solve this question. And if you have difficulty in this question, then do watch my video. So if you solve this question, then it would be very much easier for you to understand this question as well as the solution. So once you solve this restore the array question, then try to do this question yourself. Try to solve this question by yourself, and if you face any difficulty, then watch the video, right? We will discuss all the approaches part in this video. So guys, now talking about the question, here you are given a string s of a length and it consists of digits, and at the end what you have to do, you have to find number of ways to partition a string. Okay, you need to find number of ways to partition the string. Now what is a valid partition? So here there are some condition of a valid partition. So first condition is there must be only k partition, means not greater than k, not less than k. There must be exact k partition. Okay. Further, each partition consists of the substring, right? Then the substring minimum length should be m, and the start of the substring should be with an even digit and the end will be of odd digit. Okay, clear? So we need to find number of ways we can partition this string satisfying this condition. So this is the first condition, that there must be exact k substring. This is the second condition, that each substring must be of a minimum length of m, and the third condition says that the starting of the substring must be with an even digit and the ending must be with odd digit. So keeping these three conditions in mind, we have to find how many different ways we can partition the given string. Okay, clear? So this is the test case. Here it is given. So the test case, let me show you here. So here you are given the string s of a length 9. So n is this is the length of string s. Now m, this means the minimum length of each substring in the partition. So that is 2 here. Okay, and k means total partition number of partition, you can say, that you have to make. Okay, so here you have to make exact 3 partition. Now as you can see that these are 3 possible answers that I have listed. So if you see this 43 partition, 23 partition, 8, 7, 4, 2, 9. Now here this first partition, this first substring start with an even digit and end with odd digit, right? So the condition is satisfied, right? See, there are 3 conditions. Condition 1 is exact k partitions. Condition 2 states that minimum length of substring must be m, and condition 3 states that start with even digit and end with odd digit. So yeah, the third condition, you can see that the start with even digit and end with odd digit is satisfied. Now the length of the substring is 2, so m is 2 here, so it is also satisfied. Okay, now look forward. This is also satisfied. Condition 2 and condition 3 satisfied. Here also condition 2 and condition 3 satisfied, and overall we have 3 substring generated, that is 3 partition we have done. So guys, this is one valid answer, right? Now we have to find how many such other valid answers are there. So another valid answer is this 4 2 3 4 3 2 3 partition 87 partition 4 2 9. So this is second valid partition, and the third is 43 partition 2 3 8 7 partition 4 2 9. So guys, this is third valid partition. So in total we can form 3 valid partition for the given string s. So yeah, that's how this question is solved. Okay, now guys, we have to think of how to come up to this answer, right? We have to think of this. So as you can see that for each letter or for each digit, you have some choices, right? You think of this way, that there are some choices to either to include in current partition or current substring, and second, start a new partition or new substring from that. Okay, so there are 2 choices. Either this, let's say talking about this digit 3, either, so talking about this digit 2, either it can be part of this first partition as you can see here, or the new partition as you can see here. So each digit has some choices, and based on the choices you can derive this number of ways, correct? About this. So since we have these choices that each digit can be a part of either current partition or new partition, okay, see, whenever you face this type of question where nothing else can be applied, see here binary search doesn't get applied, Here greedy approach like sorting isn't get applied. This is neither a tree or a graph like problem, right? Here if you try to think of a 2 pointers, then also you won't be able to find number of ways, right? So by eliminating the different algorithm or different approaches, the only approach that remains is to check whether we have some choices or not, and based on the choices we can write a recursive solution. This must be the first step whenever you see such question in the coding round, right? To eliminate the algorithms or data structures that won't be applied to derive the solution. See here in this question, priority queue, so like heap, mean heap and max heap, then map, then set, this type of data structure won't give any result, right? So when you come across a situation where nothing is getting applied, then try to think of the choices, that is there any choices that we have to make to form the answer. So yeah, here we do have a choices, right? Each letter can be a part of current partition, or we can start a new partition. So this way, this must be your thought process by eliminating the different approaches, so that you can come to the remaining approach that can be applied here, right? So and for that you must have an idea of all the different algorithms and approaches to solve the question, then only you can eliminate them, right? So yeah, so guys, now let's take another example to see if the n is 3, n equals to, let's say 6, m is 2, k is 2, and string s is 2 1 4 3 4 1. Okay, this type of string you have. Now how you will derive your answer? So what we will do is we will draw one recursion tree to get better understanding. 2 1 4 3 4 1. Now for the first digit, as we have talked about, for each digit we have two choices, but since this is the first digit, we have only one choice to start a new partition with that string, with that digit. Now for the second digit, what is m is of size 2, so we have to continue in the same digit, right? 2 1. Now the third digit is 4. So guys, here we have two choices, either to continue in the current partition or to make new partition. So whenever we make a new partition and end the current partition, we will also check whether the partition that we will end, does it ends with a odd digit or not, and the partition from which we are starting, does it start with an even digit or not. So this condition number 3 we must check during this. Okay, got that? Okay, now talking about this third this digit 3, again we have two choices, that is 2 1 4 3 or start a new partition. But let's say you are starting a new partition, but is this valid partition? No, this is not valid, because this partition, this last partition doesn't end with an odd digit, and this new partition doesn't start with an even digit. So the condition 3 is not satisfied, so this is not a valid state, we won't proceed. Here one choices would be either you do 2 1 4 3, or let's say if you are trying to do 2 1 4 3, like starting a new partition here, but this is also invalid, because the condition 2 states that the minimum length should be m. Here the minimum m is 2. Is this partition is of minimum length? No guys, so that's why this is the wrong state, we won't proceed. Okay, now take this digit with 4. Here we have two choices, 2 1 4 3 4, else 2 1 4 3 4. Now is this state a valid? So yeah, you can see that this first partition starts with an even digit and ends with odd digit, and the second partition also starts with an even digit, so this is a valid state. Now this is another state remaining, so here also we have two choices, 2 1 4 3 4 or 2 1 4 3 4. So yes, we can make a partition here, because this last partition or last substring end with the odd digit. So yeah, we can end and make a partition, and since the new digit that we have is an even, so we can make a partition before it, right? Now the last digit remaining is 1. So for that also we have two choices, 2 1 4 3 4 1, else 2 1 4 3 4 1. From this also we have two choices, like 2 1 4 3 4 1, or if you try to generate this state 2 1 4 3 4 1, then this is invalid, because the last substring is not of length m. Okay, now let's try to generate this 4 3 4 1 or 2 1 4 3 4. Can you generate this? No, because the last substring doesn't end with an odd digit, so the condition is valid, so this is not a valid state. Now for here, let's try to generate the state 2 1 4 3 4 1 and 2 1 4 3 4 1 4 1. Is this valid? No, because the condition 2 of the length and condition 3 of the start and end doesn't satisfy, so this is wrong. So guys, these are the ending partition or remaining answer that we have got. See, this is one answer, this is one answer, this is another. No, this is not valid because the last partition is of a length 1 and this is one partition. So this 1, 2, 3, 4 other partition. Now we have to check whether how many of them satisfy this condition that they must have exactly k partition or 2 substrings. Here we have 3, so this is not a valid. Here we have 2, so this is valid answer. This is also valid answer. This is not valid. So yeah, we can say for this question our answer is 2. So 1 is this partition 2 1 4 3, and 4 1 2 1 4 3 partition 4 1. See, it starts with even, ends with odd, starts with even, ends with odd, and at least they have m size of substring each. And another valid partition is 2 1 partition 4 3 4 1. So this is second valid state, right? So guys, this is how by making the choices, keeping the conditions in mind, we can derive the decision tree, and based on this decision tree we can write the recursive code. Okay, now moving on to the coding part. So until now, if you have understood that what we are trying to do, the coding part is very much simple for you guys. So this is first approach that I have tried to write. This is the first recursive solution, the solve function, where we are passing the m, k, the index of the in the current string, the partition count, current substring length, and the string s itself. So guys, you can see that this variable is changing variable, this variable is changing variable, and this variable is changing variable. See, these are the conditions that we have to keep in mind. That is, the current substring length must be at least equal to m. The partition count must be exactly equal to k, right? So these are the two conditions we need to satisfy, and for that I have taken these two variables. Okay. Now, if the index is pointing to the last character, then what I will do is I will check is if the partition count equals to k, if this is the condition, and the current substring length plus this last character. See, we are at the last character, plus adding the last character, does it equal that is greater than equal to m, that is the minimum substring length, and is the last character an odd digit. So if these three conditions satisfy, then I am returning 1. That means we have found one possible way to partition the given string as. So that's why I return 1, else I return 0. Okay, and here I took these two variables base 1 and base 2, and I check this condition. See, what I checked is if the current substring length plus the current character, if that is greater than equal to m, okay, and the current index is odd index, and the partition count is less than k. See, in the first way, what I am trying to do here is I am trying to make a partition. Here in this I am try to make partition. This is the condition that I am trying to check here. That is, if you want to make a partition, then the current partition length must be greater than equal to m. The ending digit that is present at the index must be an odd digit. The partition count must be less than k. If you will make a partition, then it will increase the count, right? So for that check, I have added this condition, and the index dot size must be less than means index plus 1 must be less than the s dot size, because if you want to start a new partition, then there must be some digits remaining, and the next digit, the current digit is index idx, the next digit idx plus 1 must be even digit. Okay, so this all the condition I kept here in this if block. I check if all these conditions satisfy, then only we will make a partition. And if you make a partition, then what I did is I increment the count of this idx by 2. Okay, because the next character, that is idx plus 1 character, is already checked here. So that we will check next to next character, increase the partition count by 1, and also pass 1 as the current substring length, because this idx plus 1 would be part of a next substring and whose length is already 1. So yeah, that's why I passed 1 here. And in a way too, this is simple, that we are not making a partition, so just increment the current substring length, partition count would remain as it is, and check for next character. So yeah guys, at the end I return base 1 plus base 2. How so this summation will give us the total number of ways by which we can make valid partition in the given string. Okay, so yeah guys, understood this. That's in this if block I try to handle all the different conditions. Okay, so if you look here, that there are multiple changing variables, right? This is one changing variable, this is second changing variable, this is third changing variable. Then I thought that somehow, if possible, then can we reduce this number of changing variables here. So what I thought is, see, minimum length we need m, right? We need m for each substring, we need m. So I just thought of somehow can we neglect this. If we don't have, then can we form the answer? So based on that thought, what I did is I run a for loop here. I ran a for loop and handle both the choices. See, this ways one is nothing but choice 1 and choice 2 that we drew in this diagram, right? These are nothing but the choice 1 and choice 2, either to make a new partition or to include the character in the current partition. These are nothing but choice 1 and choice 2. Now if we don't have this variable, then we have to think of some way to handle this choice 1 and choice 2. So what I did here is, this is also recursive code. So here I took index and partition count, these two changing variables. I check if the index is equal to s dot size, then I check if the total partition count equals to k or not. If this condition is satisfied, then it will return 1 or else 0. If this is not equal, then it will return 0. Now if at any point partition count is greater than k, then also return 0, right? This is invalid. Now I check if the partition count equals to k. So if this count is equal to k, that means the current partition would be the last partition. See, if the count is equal to k, then whatever the characters remaining, that would be the part of the current partition, right? So and I check if the current partition size should be greater than equal to m, right? I check for this, is it greater than equal to m? Okay. Also there would be one more condition that hit my mind, that is, and as of s dot size -1, that is the last character, modulus 2 must not be equal to 0. Okay, and this condition is also satisfied. That is, the last character not equal to 0, and the current that means the last character is odd, and the current partition has size greater than equal to m, and in that case I return 1. As see here, these are the ways where I will add the count. So as we have seen that there are two choices that we need to handle. So yeah guys, here I have handled the two choices. See, one choice is this is nothing but a make a partition. So if you observe this guys, I have started this loop from idx, that is the current index plus m minus 1. That means I have already taken m characters in the current partition, right? And then because this is how I started this for loop, by from this character, after taking m characters in the current partition, I started the for loop. Now I took this variable current number and the next number. Now in order to make a partition, what is the condition? See, one condition is the current partition should be of length m. This is satisfied. Then the second condition was that the current number must be odd and the next number must be even. Then only you can make a partition between them. So yeah guys, that choice of making a partition is done here. Okay. And since this for loop will run, this for loop will handle what? It will handle choice number 2. That means include in current partition. So there were only two choices, either to include digit in current partition or to make a new partition, So this is the choice of where we make a new partition, and this for loop will keep on adding the digit to the current partition. So yeah, this is handled by the for loop, right? So this is one way of solving this question. Okay, got it? Now guys, once the recursive code is ready, then it is very much easy to write memoization code. See how many changing variables are the index and the partition count, that is the n and the k, right? So that's why I created this dp of size n and k. But before creating this dp, I check whether the first character of a string has, if it is odd or the last character is even, then I return 0. See, I just displayed 0, because if the first character is odd, then we can never start the partition, and the last character is even, then the last partition would be invalid partition. So that's when both the case I just return 0. And in the else, what I did, I took this dp of size n into k and stored -1 and call this solve function, this recursive function. I add this simple code to check whether the value is there in this dp or not, and at the end I pass the ways inside the dp. I store the answer, right? So the other code is the same as it is. I just took the modulus to handle the integer overflow, and yeah, the dp code is very much simple. Memoization is simple. So yeah guys, I hope you understood the thought process, the recursive solution, the code, and how we can write a better recursive solution by minimizing the number of changing variables, and then the memoization code. So yeah, this is how step by step we can build up the approach and write the answer. Now talking about the time and space complexity, the time complexity here is nothing but n into k, that is number of characters or digits in a string into number of partition that we have to make, and space complexity is also the same, because of n into k plus some recursive stack you can tell, but overall it is n into k, right? So yeah guys, that's all for this video. I will also upload the code inside the GitHub repository, and I will link the repository link in the description. So yeah guys, that you can check this out with this name, Google OA with ways to partition the digit into k substring. So yeah, at that I will link all this code, also with link the discuss section where you can find the problem. So yeah guys, that's all for this video. If you guys have any doubts, then do let me know in the comment section, and make sure you like this video, share it with your friends and support the channel. Thank you.